and now we just need to define the size. So by default, as I remember, the scale factor for our particles which have been spawned is 100%. So in other words, if we've got a parent particle which is 1 unit across, our spawn particles will also be 1 unit across. So as you can see here, in our particular flow that I've actually set up, I've actually set this to 22%. So you can see that our spawn particles are actually much smaller than their parent. The next option is we have a variation, and again it's a percentage, and you can see that we have a choice here of actually having some variation on the actual scale which is inherited. You can see I've actually set it to 57% here, and this is a positive and negative option. So this will actually mean that our particles will start off as being 22%, and obviously they can be plus 50% on top of that number, or minus 50% on top of that number. So you have a range between 10 roughly and say 33, something like that. That's the actual range that you can actually have on the scale of our particles. So that's it for the spawn particle test. Let's have a quick run through of what we've actually got going on here. You can see I've actually got a source, and that's firing particles down. They've actually got some speed there. You can see I've got some speed. I've got some gravity in the scene, so that when our particles strike and they spawn new particles, the spawned particles actually have some gravity to pull them downwards, and that will actually make them bounce off this spherical deflector a few times. So if I press play, there come our particles, and there you can see as they strike they actually spawn new particles. Let me just play that again. There you go, they're spawning particles. Now I've actually changed one of the parameters here, which is actually changing this particular example away from what I want it to be, and that is actually the parent particles and the spawn particles. They're both allowed to live. What I actually want to happen is it to spawn on first collision, and for it to actually delete the parent particle. So now if I press play again, there you go, that's actually the simulation that I wanted in the first place. There you go, they come down and it bounces. Let's actually go to the collision point, and let's change the variation slightly, so we have more chances of having 4 particles. And let's actually change the offspring number. Let's make that a bit higher. And the next thing is we've actually got quite a few particles there, but you can't actually see them. And the reason for that is we're inheriting 240% of a parent speed, and we've got no variation on that. So let's put a little bit of variation in to show you what happens. See how the particles are now spreading apart? So what was actually happening was all our particles were sitting on top of each other, because there was no random variation in the actual inherited speed. There you go, so I can actually spread them out that way. Now another thing you can do is you can actually add some divergence to the direction of the speed. So let's try that. And you can see that's actually having a much better effect. The particles are heading out in a sort of random direction. Obviously you probably want a bit of both, so we'll change the speed. So we've got a 30% variation in speed, and we've got a 12-degree variation in travel. And now if we play, we'll actually get something much more like what I actually was aiming for in the first place. So there we go. This is something which we'll actually use a lot in the 5th DVD in the series, Practical Examples. In that DVD I'm actually going to show you how to take everything that we've learned in the previous 4 DVDs and put it into effect in real world scenarios. And spawn and spawn test, spawn and collision spawn are 2 very common tests to actually use in any of your flows. So we'll probably come across one flow at least in that DVD where we actually use this test. Okay, let's move on from here and have a look at the next test, which is the find target test.